Hello, welcome back. Today we are going to talking about the Lab 3 Week 2. And in this video recap, we will cover about how to use the assembly code to finish the second part of Lab 3. So let's go to our website first. And let's open the Lab 2, the PDF file, to see the introduction. So on the page 4, I think. Here is the requirements for the week 2. And the task is translate these C code to MIPS assembly code. And we can go through this code for really quick. So first we print a number. Sorry, we print the numbers. This is a string. And then we define a variable x. Actually, this is an array with 8 elements in it. And then we iterate each one and print them on the screen. But here is a typo. This should be ENDL. And then I click tab in the code here on the left. You can see this the C++ code. And print the number and this array and print the each atom. Okay, so let me run this code for a quick to show you what's the result. First I compile it and then I will run it. Okay, here are the results. So first we need to print the numbers and then print each numbers in a separate line. So there are two things. The first is print string and then print integer. Okay, and after this code, here's some tutorials for the assembly code, how to print an integer and print a string. So last week we covered about how to print an integer. So if you still remember, number 5 system call is read from the keyboard, and the number 1 system call to print an integer. So number 1, and this is the system call number. Before you call the number 1 system call, you need to move the value you want to print from the t-type variable to the A0 variable, because the number 1 system call only knows how to print the value in A0 on the screen. So this week, the first thing we want to learn is how to print a string on the screen. The string, the same thing, the string system call number is number 4. Okay, pay attention to here. It's number 4, not 5, not 1, it's 4. And the first step is also we have to load the string we want to print to the A0, but we use another instruction. It's called LA, load address. It's not Los Angeles. It's LA instruction, load address. So we load from str1. This is a variable predefined in the data segments. I will show you later. So and we load this address to the A0 and then call the number 4 system call, and then you can print the string on the screen. So let me show you. Here is how I define it in the text, in the data segments. First I define string 1 column. The type is ASCII code, and here is numbers column, and use a double quotation to do that. Second is enter, and then is my array X, and the type is word. So, and we have 8 numbers here. So this demo is show you how to print a string. So first I use LA instruction to load str1 to the A0, and then call the number 4 system call. So you can print this on the screen. So let me quick to show you on the how it is on the QtSpim. So open the QtSpim and initialize and load the file, change the file type, and find the file. You can just run the step by step to see how the data transferred with the register. But right now I just click the green arrow to run it because the code is ready. Okay, so I just print the first one, the string, numbers column, this is a string. Is equivalent to cout numbers. So when we print a string, there's the automatically enter here. Okay, so that's the first demo, like how to use the print string. But when we print numbers, there's no enter automatically to put at the end of the line. So whenever we print a number, we need to print this string manually. So that's the second step to do this. So I want to print the first element in this array. So how to do that? The first, we print the numbers, and then we defined a variable I, iteration variable I. I name it in S0. So this line is just reinitialize it S0 to 0. And then load X, still use the load address LA instruction, load X to S1. So the base address of the array X is in the S1. And then just like your homework, read the element. The first element is in S0. So first, I left shift 2 bits for S0, which means is the index number times 4. And then add the offset with the address, base address. So I add them together, get the new address into the T0, and the load word from this T0 to T0. So right now T0 actually is the first element in this array, is 18. And then I print it. So when this time when I printed T0, actually T0 is an integer, so I used number 1 system call. And before that, I moved the value from T0 to A0 and call system call, exactly like the first week. And then I print the enter. The enter is stored in the second string. So I use the LA instruction load from the str2 string 2 to the A0 and call the number 4, which is print the string system call. And that's it. So let's run this code to show you the results. Open it. You can just run step by step to see the register transfer. But right now, I just show you the results. Okay, since I just task to print the first element in this array, so we have numbers, and the first item 18 and an enter. So here's the prompt is here, so which means we enter the number. So if we don't print the string 2, the next number will print after the first one, so which is wrong. Okay, so the next step is to do the branch, okay, and the loop. So that's the second step. Okay, how to do that? Okay, the first we needed the tag. So the tag is indicate the position. So you can use the J-type instruction to jump to the tab in this code. Okay, and also I put the done here. Okay, so let's go through the code. So after I print the first element, and then I will check the boundary. So I use the set less than SLT instruction. So the functionality for this instruction is compared with the value S0 and 7. The S0 is the iteration variable I. So this sentence means if I less than 7, I assign 1 to T0. Else I assign 0 to T0. Another word, if S0 less than 7, T0 equals to 1. Or T0 equals to 0. So the next sentence is the branch not equal. It's a jump type instruction. It's branch not equal, which means if T0 not equal to 1, I jump to this tag. So which means if T0 not equal to 1, which means S0 not less than 7, which means we touch the boundary. So which means we should end the loop. So we go to the done. Done is the exit. Okay? So this is the one. And please remember, whenever you use the branch not equal, put a no up after this instruction. So these two lines as a wrapper. Whenever you use the branch not equal, put a no up after that. And then, so if we don't jump to the done, we continue, which means we haven't touched the boundary yet, so we can do the iteration variable I++ here as S1 equals to S1, S0 equal to S0 plus 1. And then we do the J is another jump instruction to the loop. Go back to the loop to load the xi again. So because right now the S0 is already increased by 1, so we can get the second one. Okay, so let me show you the final results. So load the file again. Okay, and run the code. You see, that's the final results. Numbers and each numbers. Okay, so that's the second part for Lab 3. And so finally, just give this screenshot. On the left is your code, and on the right is the results. And have the screenshot. This is the second part of the Lab 3. So see you next week.